So we have this function here, piecewise, one piece for x being less than -4, the other greater than -4. So if I were to just kind of rough sketch this out, axis there, another axis, ooh, that's the eraser. That again, another axis over here. And then I'm gonna put, let's see, 1, 2, 3, this would be -4 there. Just gonna draw a little dotted line there because that separates the two parts of this. And we want these two pieces to meet up on this line at the same point. So I'm gonna graph the one I know here. So let's see, if we plug in -4 to that right there, what do we get? 16 minus 20 is -4. That would be a -9. So let's say this is like -10 down here. Oops, that's not a pen. -10 down here. +10 would be up here-ish. That's -4 there. +4 would be somewhere over there. So I have a point somewhere over here-ish to start out with when x is -4. If x is 0, I get -5, which is over here. And what's the turning point of that sucker? X equals -b/2a. So -5/2, which is -2.5. So the turning point of this thing is at -2.5, which is somewhere here. And I guess I need a calculator for that thing. Let's get a calculator. And Desmos has been our friend lately. The sun is shining where I am. It's a sunny day to do math. So let's see, let's just graph the parabola part. And that is x squared minus 5, no, plus 5x, wasn't it? Plus 5x minus 5. Yep. Okay, so the turning point is down here. All right, what number is that? It's kind of off my graph. F of -2.5 is -11.5 down there. -11.25, so it's kind of in my picture. So turning point is somewhere over here-ish. -2.5, 11.25, so somewhere down there. So there's my parabola coming through something like that, and who knows where it hits there, somewhere. It's supposed to be an arrow. And then I have this line over here that hits at -9. So let's draw that in green. So it's going to have an intercept of -9, which is probably over here. And then it's a straight line, and I want that straight line to pass through that point right there. And let's see, where is that line at? Calculate there. Oh, that's -9 too. Interesting. So it looks like from my picture that I want this line right here to go through that point, which would be the line y equals -9. So the slope should be 0 according to my picture, if my picture's right. And then, right, I don't really want to graph this part of it right there. I should erase that. Oops, where's my eraser? All right, so let's see, just to double check. If I plug in -4 into this function, it says use this rule right here. So f of -4, I had done in my head earlier, is -4 squared plus 5 times -4, it's parentheses, minus 5, which is 16 minus 20 minus 5. 16 minus 20 is -4, minus 5 is -9. So that's this point right here. And I want this other part to agree. I want it to meet there because I need it to be continuous. So I want my mx minus 9 to be equal to -9 when x equals -4. And the only way that's going to happen, you can kind of see here, is that I want that -9 to stay, so m would have to be 0. but we can plug in -4 and solve anyway if you don't believe me. So m times -4 minus 9, we want that to equal -9. To solve for m here, we would add 9 to each side. And we get m times -4 has to be 0. Dividing by -4, we get m has to be 0 for my version there. Let's graph to check. All right, so to graph a piecewise function like that in Desmos, let's do it. You start off with your f of x equals, and then you put a curly bracket in. And then you define what x values to use first. And I'm first going to use x is less than -4. And then colon, what do I do if x is -4? I graph y equals -9, comma. Then the next part of the domain is x is greater than or equal to -4. And if you just type the greater than symbol, then the equal to symbol, it turns it into a greater than or equal to. And then from there on out, colon, I want it to look like x squared plus 5x minus 5. And there is my function, nice and continuous through the point -4, 9. Isn't that beautiful? And close the parentheses to be a good math student.